Okay, so I have a major challenge of keeping you awake after such a wonderful lunch arranged by OHT team. And first, let me thank Leo and Sarit for giving us all. Even I am from Burma, still I am getting every time I get an opportunity to hear Sarit. There is one thing that is new, and I learn. This is not okay. So every time there is, so I would like to thank both of them for giving us such a brainstorming session. But more than that, I'm very thankful to OHT team. They have given us an opportunity to the Burma team. So also for the delicious lunch. So I think they deserve a good round of applause from everyone. And I'm very thankful to their team and whoever are the organizers. So now this will be the, you can say, the climax of our today's training. Now Burma Reservoir Management System, as few moments back we had a question that is there a solution where we can manage. So before moving into it, I will just give you a thing which is I am very proud of. So do not fill your tanks without Burma. Okay. Now let me come to the point that why I am saying this, that do not fill your tanks without Burma. So every tank has I guess maximum are the designers here, you can say. So every tank has a different command area, or what we call as an operational zone, okay, while designing. Every operational zone has a different population. Every population is distributed with a different type of density. Each density is having a different type of, you can say, use, like industrial, commercial, residential. So unlike irrigation, in water supply, each of the tank is having a different size, you can say the capacity of the tank and the inflow demand based on the downstream population. Okay, just keeping aside the peak factors and all. Okay, this is just, I'm keeping it simple and standard. So unlike irrigation, in water supply, the challenge is each of the tank is to be optimized with a solution which is very precise with respect to the flow and pressure. Because it will not happen that if the demand of the city is 10 mld and I have 10 tanks, it is not like that I will give 1 mld to each tank. It is agreed, I think everyone is agreeing to that. So each inflow is different. The source for each inflow, maybe 10 tanks might be having supply from 3 pump stations. It is not like that one pump station is only, or if it is a gravity, the driving HGL of the delivery will be different. So pressures are also different. So challenge in water supply is to precisely do the engineering and provide a control solution. Now, why providing a control solution? Now let's make it interactive, because I don't want you guys to sleep. While designing a water supply system, what are the things you are considering? Let me start with the per capita demand. Okay. So how is it the per capita demand decided, and or I can say what is the per capita demand for urban water supply? Anyone? 135 plus 135 plus. What this loss is consisting of? Remove the frictional loss. That is the major loss, okay? And you remove the minor losses, okay? Is there anything like losses at source? Is there anything losses at source? Because we are always considered about the losses in the distribution. And what about the losses at source? If you want to generate a revenue from the water, if you want to reduce the NRW, these losses needs to be considered. Now losses at source will be losses at WTP. Your reservoir is a source. What about the losses at the source? That has to be encountered. Also, distribution losses are important. We are concentrating on that. But what about these losses? Because water is same. The cost of water reaching that tank, picking it from the river, treating it, doing the treatment process, transferring it till the tank. Each drop has an amount. Okay, each drop comes with some amount. So that losses are also important, which are, we can see here right now, are usually ignored. That is what is called as losses at source. So I will be speaking about losses at source. Like losses in the distribution, Sarit has beautifully explained in the pressure management, in the distribution side. Okay. So now I will directly jump into the application. If you can see, while sources for supplying the water, I have, as per Indian conditions, I have two types. One is a ground storage reservoir. Okay, if the size is very big, or if it is to be located at a higher elevation, I will usually prefer this type. If the terrain is flat and I don't have a high elevation location or something, I will lift the tank up so that I could get that desired pressure or whatever is the desirable pressure. Okay, so the solutions will be, the products will be different for both the application. You can see here it is bi-level float, control wall, and it is a second one is modulating float. It's a very simple difference. You can see the floats. Okay, here you can have two floats. You can give preset minimum, preset maximum, so that if the tank level inside the water is reaching the lower level, the valve will open. And I don't think I have to explain more how that valve will be open, because we have seen this in flow control, pressure reducing and all, although I will go in detail. And the next is modulating float control valve. Now there is only one float. The purpose of that is, the application usually what we Barmad propose to the whoever is the client or the engineering agency, like whenever the water level of the tank inside the tank drops by 1 meter, it will open the valve at the downstream and the tank, so it will always keep the water inside the tank. Okay, now just imagine a 24/7 water supply. India is slowly moving towards 24/7. Puri has done a successful job. They are you can say worldwide famous in India, Puri. So Puri is successfully done. Now can you imagine the 24/7 water supply? We think that okay, we have a tap water, continuous pipes will be having water throughout the day. Okay, but tank filling operation is also continuous. Unlike rural water supply or intermediate supply. Intermediate supply, you fill the tank in the night, morning you open the valve, entire water goes down, that's it. The next cycle will be on the next day or maybe in the evening. But in 24/7 we cannot do that if we are designing that system. So again the tank, so draining of the tank and filling of the tank is also a continuous operation. Okay, it is not like just one time we are filling and I will be able to supply that. Okay, because I do not have that, I cannot construct that much big tank. Okay, I mean, it might be happening that I have to fill it again and again. So I am just relating the practical scenarios with the Barmad solutions. Same, this was for ground tank. The floats are the governing part of the wall. While when I am elevating the tank, I have an altitude pilot, okay, which will be helping me to sense the water inside the tank. That's why many times it is also termed as altitude control valve. Maybe you might be knowing it as while. And here we can have additional features like flow control and pressure regulation. That is like an additional feature on the level control valve. Okay. Okay, so here is a simple video. Okay, we will see how Barmad level control valve works for an elevated tank. Okay, keep in mind this is for elevated tank. Sound, I think we have not connected. Okay. No need of. Again, the question might arise that why we need a strainers, even though it is a water supply. But okay, we will focus on that. So level and flow control valve, you can see we have written two applications. Now I will add one more feature to my level control valve, that is flow control. Again, unlike irrigation or irrigation management, in water supply we have one source with multiple destinations. One pump station can provide water to 10s, 15s, 20s, 30 numbers of tanks. Okay, now water has a tendency to obviously move towards the lower elevation or to the near location. So obviously we, along with the level control, we provide a flow control feature, we can say flow limiting feature, which will provide only the set demand for that reservoir. Okay, whatever is the design demand, or we can say design set demand for that. And third feature is also there, which I will add in that, but let's first finish flow meter. Then we have Bernard flow meter, which will help us to measure the flow and provide cumulative volume consumed or provided to the tank through the entire course of the day. You can have the intervals.
Do you want me to help you to make them be awake?
Yes, sure.
Yes, I can. I have a question. What is wrong with this installation? Look on this installation. What is wrong? Where is the flow meter and where is the valve? Flow meter should be installed upstream to the valve, okay? The jets that it will get from the downstream of the valve, okay, will harm the accuracy of the reading. So this is what we recommend. We strongly recommend always to install the flow meter upstream to the valve. At the end of the day, when I come to the field, many times the contractor is doing the opposite. But it is important that you will know the right way and that you will have the option to choose, okay? Another thing I want to say, we did talk about B-level control and modulating level control. In which way the valve will work harder? In which situation the valve will work harder? Can you tell me? The valve that is controlling the level, when it's working harder, when it's modulating and maintaining a constant level, or when it has a maximum and a minimum level, what we call B level. Modulating will be much more harder for the valve because it will always regulate to maintain a constant level. When we talk about B level, when we are below the maximum, okay, it will open and fill up the reservoir. It will not regulate, it will not be close to the seat. And when we will reach the set point of the maximum, it will close, okay? It will start to close, start to throttle, and the end will close to prevent overflow. So when we have a valve that is constantly doing something, maintaining on some parameter, it's working very hard to do it, okay? Because it doesn't have time that it's fully open and not doing anything. And as I said, in this area of the seat, when we are constantly regulating, we have high flow velocity, pressure is dropping, what we talk about cavitation and all these issues, so we need to take it under consideration, okay? And what we did show that we can either use a float or an altitude pilot. There is also an issue of cost of the solution, not only if the valve is working hard or is working easy, okay? Because we can help to the valve. How do we help to the valve? We put another PD, okay? So we split the load, okay? But there is issue of cost of the solution that we are offering, and there is issue of installation. When you have an elevated tank, you don't want to get into a trouble and installing a float 5-6 meters up. The altitude pilot is like the float. It's sensing the hydrostatic pressure of the water, okay? So, and it's very easy because you can come to the valve which is on the ground, okay? And do what you need to do with the control you maintain, calibrate, etc. And you don't need to go up to handle the float, okay? So there's a lot of parameters to take into in consideration, not just the hydraulics, but also the installation and the cost, of course, that always play a role.
So this is a clear example how Israel team helps Burma India. Okay, so this is a live example of it, and thank you, Sajid, for that. So moving ahead, just like this, we will have every time it is not possible for a remote location or anything that we will have a power supply. Okay, it is not possible, especially in many parts of India. Still now it is. Although it is available for household and domestic purposes, but not for this. So we provide us RTU, which is we call as remote terminal unit, and this will be helping. This will be backing. You can see this. This is a very good installation, typical installation arrangement, and you can see how the meter walls is connected to the RTU, and in case if we have any pressure gauge or flow transmitter or something, that can also be connected to that RTU, and this will help us to provide our details and reflect our details to the control station. Okay, control station is usually our pump stations or WTP or whichever the control location is. So this is a typical installation arrangement, and this is what Burmar provides in inlet management of elevated reservoirs. And not only limited to inlet, you can connect your outlet solution also if there is any, because usually we are not restricting water at the outlet, because there is a purpose of constructing a tank at 20 meter staging height or 25 meter staging height. So we usually do not restrict it. But in case if we have, at least we can have an on and off application only, that can also be connected to this system. Okay, so what this is, it is just a simple GPRS based remote terminal unit which is compatible with the control station to monitor the devices, whatever we have seen, whatever the arrangements we have seen, and it will give all the real-time data on our control station, which is usually a WTP or pump station, and one can sit there and just see that okay, this is the demand this is my daily demand, the whatever is supplied till 3:30 is this, and okay, things are running, and remotely we can do. Now the third feature which I am adding in this is level control, flow control, and we will have remote on off. Okay, in case if you think that okay, I do not want to supply water to this, you can remotely turn on and off to the wall. It will just have a latching solenoid, as Sarit has explained already what type of solenoids, and these are in OMS, irrigation management, and it becomes ease of access of doing projects, especially to the contractors, is good. We have seen, and the current projects which we are doing and which we are going to do, the application wise the system is running well and we are getting good results out of it. And also, as I told you, it will be having a solar panel which will be powered by a rechargeable battery, as power might be an issue or you do not want to give some dedicated power to this system, so you can have that. And the controller as acted, and it is on both on auto and manual mode, and you can set the daily demand of it. Now just imagine a situation which we had now this is a control station, this is our communication and 3 tanks. Now just imagine a situation which we had a few months back, that the entire demands of the cities were diverted to the domestic demand because of COVID. It was complete lockdown. No one was allowed to go outside. The industrial, commercial and other zones were completely empty. Can you imagine a situation? Our system is not ready for this. Our pipes are designed for some certain demand, and the entire domestic demand is running and the rest of the demand is not working. Where the person is not allowed to go outside, how can you ask them to operate, go, close the tanks? No one is going to drink water from that. Do the interconnection, transfer the water to domestic areas, everyone is sitting at home. This is a benefit of that. Just sitting in the control station and having this with least amount of energy required, you can say negligible amount of energy, because only energy required is to give the signal to the wall to make it on and off, which is also, you can say, it is not taking energy, it is just a pulse which it is taking. Okay, it does not require continuous energy like the conventional motorized valves, or you can say electrically actuated valves. Okay, so this will be a dashboard at your control station, which again Burmard will provide. You can see the number of tanks. Just assume this is a real case from Karnataka. Okay, and when you click it, you will get the details. What is the wall status? What is the daily demand? How much is supplied? So, don't you find it user friendly, irrespective of you being a consultant, contractor, or whoever? And these are some of our installations, what we saw in pictorial representation. This is a project in again Nanjangud, Mysore, where the project was of 27 locations. See this number of tanks for one project, 530 tanks. Okay, this project is now in operation and maintenance, which is in again Karnataka and Narsikre. And again, we can see how the different tanks have different types of installations. Okay, this is from RC, correct? Okay, and for elevated tanks, you can see how the arrangement is. Although they are suitable for vertical, horizontal, both the installations, but I would request you to consult us first because it depends case to case basis. Like this, you can see here. Can you see this pole? And this is an RTO mounted here, okay, which is very near to the installations. The only requirement for the RTO is it should be shadow free because it has a solar panel. That's it. It does not require any some rocket science or high-end engineering. Again, we are VLs. This is a 24/7 water supply project in Ranagani, Karnataka. This is again in commissioning stage. So this will be commissioned soon, where Vermont provided level and flow control valves. One valve with two applications, level and flow. So previous one were from rural multi-village supply. This is from 24/7 water supply.
You can see that back two walls are there, back to back. That is proportional here.
So what we said that multi-stage reduction, we can see when the ratio is going above the reduction required ratio. So this is the arrangement what we are providing. And this is the float, which is the governing giving the wall is sensing through this float that how is to be operated. Maybe it is some dark image, but you can see the water here and how the float will move up and down here. And this is the altitude pilot for elevated tanks. Watch what we discussed. This is a wall with all the control within, and this will be the altitude pilot. And the list is long, so if we cannot control it, we cannot save it. It's very simple. So that's when we talk about saving water and doing huge projects. So maybe you can ask your questions not related to level control, related to surge, OMS, pressure management. Sarit, Pushkar, me and our teams can help you with whatever your queries are.
I'd like to add one question to the PRV related. What are the solutions apart from BPT, break pressure tank, that can be provided with respect to the PRV?
PRV?
Yes, yes.
All what we discussed was PRV almost to the replacement of BPT to upper network station is one application that we use pressure reducing valves. Okay, we talked about it. It was a very big field in package 21, and the system was designed for 100% of the flow, and until we will reach 100%, it will take few years. So we needed to take into account scenario that the pressure will be much higher due to the fact that the consumption is increasing in stages, 20%, 30% of consumption. This was the upper network as a solution, this mega station for an alternative solution to BPT. But in the beginning, all the examples that I gave you for PRV, when we are in a zone close to the pumping station, we can reduce the pressure using a PRV. When we are going downhill, we need to take into account reducing the pressure along the gravitational line, okay? What else? When we are in different flow variation, when consumption is changing, okay? And some shifts are now closed and the pressure is increased. We need to take into account changing pressure due to changing demand, okay? So actually pressure reducing is the most common application, and it's spread all over the area. Okay, and you saw it also in municipality when we talk about the pressure management. The solution is pressure reduction. It can be done either standard, it can be done dynamic, it can be done proportional. But at the end of the day, almost all the applications that we talk today, besides the flow control, are pressure reducing.
I have a problem. The project we are handling right now, it is a very remote part in India. At that part, the approach is not there. I cannot go to the ESL level if I say so. So client is very adamant to remove the PRV in this case. He doesn't want to provide PRV for this entire area, the entire network. So for that, what will be the solution? Right now we are discussing with Mr. Amay and Mr. Pradar sir, but there are some options which I believe you can suggest us.
Okay, can you explain more about this project?
The client is saying they don't want to use PRV in the system.
So
Because
we've got a pump station. Our last PRV needs a pressure of about 200 meters, but along the line there are about another 15-20 tanks in the middle, which don't need 200 meters. They don't need 20 bar. They need about 10 bar, some 15 bar, some 12 bar. Two constraints that the client has given us. One is they don't want single stage pumping more than 150 meters. And secondly, what they are suggesting, and this comes back to probably my question in the morning as well, is where the client is saying that you will install these PRVs, it's fine. On theory and on paper it will work, but then in their opinion, PRVs often fail. And when PRVs get offline, they're not very easy to get back online, and they're not very easy to maintain. That's what the client's thinking is and mindset is. And so that's where we are struggling, because we've been asked to put probably break pressure tanks, which actually, or intermediate pump stations, which doesn't always make sense. So that's where he's coming from at the moment, that our locations are such that they're not easily accessible. And so if we do have PRVs, then how do we maintain it and keep it running over a period of, say, 15 years?
First of all, I think, I don't know, I think it's more a psychological question, because we need to educate and to make the client realize that other solutions besides BPT are working, and are working all over the world with more than 40 years, 50 years of experience.
Maybe firstly is important to say that PRV doesn't need any maintenance. I mean, if the condition of the system stays, so
that's why I said it's psychological.
Yeah, because they are not really a problem. Once you calibrate it, it's there forever. Unless the condition of the system may change. But if they are not changed, it's there forever. So I think that the best way to try to tell him, let's try in one place. Only in one place, and then show him that it actually works, or take him to other places where PRV is installed and talk with the customers. The best thing, if we say something, or you, in this, we are the supplier, of course we have interest. But if you ask other farmers, they will tell you what they think, and maybe you will be convinced that it doesn't have to spend so much money. And
we can help you to, educate them if they want to see the real installations what we have. Because if they want to reduce pressure but they don't want to install PRV, it's like they want to see a tiger but they are afraid of it. So it will be similar of that. So we can help them, we can show them, let's see how the systems are running. Because it is not only about speaking, but we are getting many things like from 1990, 2000, Burmah walls are installed, and now in 2022, after 22 years, there is the first issue which they are facing. Okay, so it's not like that about the same. We can help you, we can help them, we can help obviously the designers also, that how it is installed, how the selection was done. And he correctly said, as I wanted to add, do it at one place as a pilot. If they satisfy them, then again we are here only. So we can help them with that. So educating them may be the only solution.
I believe that can be arranged. I believe that can be arranged.
Yeah, I believe that when the first cars came, so the first motorcycles, people were sure the donkey is still better than motorcycle, but in the end,
Because we usually hear this that
Diaphragm operated valves, what if diaphragm operated valves fail? Because it is not a first time question, but if you want to be so much critical, then you can be critical. What if the tank falls? That can also be a situation, but still we are constructing it. What if the pump burns out, but still we are installing it? So it is not like it is. If proper engineering is done, nothing will happen. At least I can see that. But the first thing is proper engineering should be done. It is not only just give them the wall and go and tell them to go and install it.
I'm not jealous at you because I never sold one valve in my life. I'm not a salesperson. I'm an engineer.
You have now the first opportunity to go with them and convince them to buy.
So I'm not envy at you, but I think it's also really because India is a growing market and it's developing. It's also an issue of the seminar that we did today is to open the mind of people that there are other solutions and they work for many, many years. Maybe they were not applied in India in this area or that area, but you should make them aware of the solution, of the benefits, okay, of the challenges that they answer, and we can show references very easily. So it's a little bit of job of education of the clients, of the customers.
And by the way, if this customer has son, children, work with him, usually it's better. It's easier to convince the young people because they are more open to new technology. But this is true. We are in a very problematic business that all the farmers, they are very conservative and they are afraid of new technology.
Anyone from that side?
Other questions?
Any questions?
What is minimum operating pressure? Pressure control.
Hello. What is the minimum operating pressure of pressure and flow control?
It doesn't matter if it's a pressure and flow or just an on-off valve.
On-off.
Minimum operating pressure for 100 series, let's say, is 6 to 7 meter line pressure. Okay? Yeah.
In that aspect, maybe it's wise to mention that we have Irrigation, but they operate in all and special, yeah. No,
But we can, for special low pressure application, we can apply special control loop, special valve configuration to make it a better actuation pressure, okay? 5 meter, something like that, okay? But you should advise with us, okay? So we will give the most technical, correct solution.
the question that you raised, I will answer in a wider point of view, because there is always the standard and there is always special condition, especially in agriculture. That each farm looks a bit different. So we have the standard products that we believe that cover 85% of the requirements, and this is the high runner, and they are standard, and this is what we put in the catalog and everything. But Berman can bring or develop or design special solution for special cases. If someone has a different topography or a dramatically low pressure or things like that, we know how to solve these things also with our product, with small modification, with the control loop and stuff like that. It's not a standard product because you can find it here and there, and it's required from us a special treatment. But if there is a need, we know how to answer to these special questions as well. Okay, so this is two segments, the high runners and the special requirements that we know to answer.
Actually, in Maharashtra, most of the projects are gravity-based irrigation projects, primary distribution network projects. In these projects, chucks forms. Some of the chucks get more pressure, some of the chucks get 2 to 3 meter pressure. So there is a chances of unequal water distribution. In this case, this option, this wall is more useful, but below 5 meter pressure is not operating. No?
Yeah.
We can also use external pressure for opening the valve, okay? If we have some kind of external pressure source, we can also apply. I'm just sending you some options that we did when we were asked to do special things, okay? But I wouldn't lock myself into numbers 5, 7, 10, I would just advise with the team, because as Lior said, we are expert in giving tailor-made solutions.
Wanted to ask, in this kind of situations, and we are normally open or with fluid limiting. Is it an option that can be given? Sorry. In these situations, can we have normally open valves? Because I was can we have normally open valves which are always open and have a fluid limiting feature on it, so that we don't need any pressure for the valve to be open.
When valve is not flow limiting, that should be
Yeah, it should be normally open.
I think it's possible. I think it's possible. We should do something with the spring. We should do something to make sure that the valve is normally open. But I think it's possible. It's a different control loop that we will apply.
Yeah, just have to justify it commercially. We won't do the effort for one valve or two valves, but if there is a project, we know everything about right, we can do it.
We are still in
We did it, by the way, in the past, but we went through the market. We had also in the past system that worked in 2 meter pressure, but it's very unique. People buy a pump and try the pressure.
But we are well aware that low pressure irrigation exists, mainly in places like India. So Lior is also dealing with giving other solutions, not just pressure reducing and flow control. We are talking a lot about issue of lay flats, all this type of low pressurized irrigation to give solution for such systems.
My question is regarding surge. Can we propose NRV or SEC valve in the pipeline for surge protection devices, as a surge protection devices, but not in the pump house? Can you use that? Can you use NRV or SEC valve in the pipeline to counteract the surge, but not in the pumps?
I think zero valve is something like this, no?
No, not JDV. Basically, asking the NRV or SEC valve.
So you mean to say not near the pump station, but somewhere
Along
along
the-
the
Along the line.
Why? To protect the pipe.
Yes.
Yeah, we actually, I'm smiling because we actually deal with, we think about developing something like that will be very economic regarding the cost of it. That will protect what Sarit mentioned, the lay flat or the flexible pipe that are very, or other pipes that are very sensitive to pressure, and to protect these pipes from occasionally high pressure hammers or something like that. You can use the equipment today, but it's cost a lot, so we probably won't put it in many places in the field. But we think about developing something that is very economic, and then next to each valve you will be able to connect it before the pipe that you want to protect, and it will be 100% protection. Yeah. We think about it. That we'll have a PRV to manage the pressure, but also a quick relief valve. So if you will get kind of water hammer or surge into this pipe, we release the water locally, not So if you ask, you believe that there is a need for such a thing?
Because I've seen on design, they have proposed NRV in the pipeline. So I thought better you guys will be the best person to answer this question.
Yeah, we believe that there is a requirement that today people use higher grade of pipes, because that in case of any water hammer, the pipes will not burst, will hold it. And if we will bring this component, people will be able to use a lower grade of pipes, which cost less, and then save money on the irrigation and be sure that everything function.
Maybe you can share from your experience, because I know I saw in India some projects with the NRV along the pipelines.
Yeah, I mean, like, to answer the question, yes, we can use NRVs. Ideally, to okay, just the concept of surge is like one is in the pump station where we control, where we put our bladder vessels, our surge anticipating valves, or all type of solutions in the pump stations. When we have long running pipelines, and when from the pump station to your highest peak point, the static difference is higher. There are different solutions which ideally ZVV is zero velocity valves, is used close to the pump station as well as in the static lift. In the static lift, ZVV is nothing but a spring loaded check valve and with a bypass arrangement. The purpose for it is to break the static head. You don't want your water column from the once your pump fails and the water column is like from a pump station, it goes all the way to a peak point. You don't want that static drop to happen. That is the reason they put in check valve in between or NRV in between. ZVV is the same thing, but it has got bypass arrangement because once your check valve or NRV closes, there is one more surge that is created. Second wave of surge is created close to your check valve.
Also maybe a column separation.
Yeah, column separation will happen obviously. So there will be a need of air valve. So what ZVV? There is another solution which is ZVV, which actually passes that 1/6 of your water back to the system. So that is another solution which is people use in India. So yes, it's an option. It's an option for your line where your static is higher.
But when we talk about controlled NRV, we should know that some of the water might get to the pumps.
Yeah, no, I mean, like I agree. Like, look, I mean, this is a solution in the distribution, like in the rising main, far away from the pump station.
So as like just like a thumbnail, if you have like say a pipe of diameter 300 millimeters and a length of 5 kilometers, how many of these ZVVs you would propose?
And May, also, do you have an input on the operation and maintenance of such check valves compared to Vermat solution?
Look, okay, I'll answer his question just first. What he asked is in a line length of 5 kilometers, how many ZVV is required? It's not about kilometers, it's about how many peaks or that we have. So ideally, if we have a flatter terrain and 5 kilometer one single line, I wouldn't recommend that. But if we have a terrain which goes up and goes down and again goes up and down, I would recommend two places to have an equivalent. So usually it has been considered whatever number of big peaks, that many ZVVs are required. Coming to the question of what you said, Sari, is about do we have comparison? I mean, like ideally, I would say that the surge anticipating valve or even your bladder vessels, which are more towards your pumping station, is controlling your pumping station. But if we have long running lines, because in India, in the river linking projects, there are big dia pipelines which is running from source to say about 50 kilometers, 60 kilometers. We cannot obviously have such solutions only at the pump stations. So in between, wherever required, there is a need of quick pressure relief valves in the system. There are some places where, example, I just link with Gujarat project of this Savni Yojana and all. These are 18-meter head pumps, 18-20-meter head pumps, but lifting huge amount of water towards long length. In that case, there are open surge tank as well, because head is not much. So comparison wise, government solutions for most of the cases it is applicable. 80 to 90% it is applicable, but wherever there is long running pipelines, we need, apart from the SABs, we need some other as well in between.
Ma'am, we discuss about pressure control valve. Ma'am, we discuss about pressure control valve. Can I use a check valve, or gate valve as a pressure control valve by by closing it to certain level? And if I will use such thing, then what effect will occur to my pipelines?
Can you hear me? Okay. So a gate valve or a manual valve is definitely breaking the pressure, but it will not change its position if you will not change it manually according to the system condition. Okay, so a gate valve is also mechanical pressure reducing valve, right? So I don't know, you call it mechanical, I call it a man valve. Someone has to come and to do something. It's not doing automatically. So this is the disadvantage of a mechanical pressure reducing valve. It will not react, it will stay in the same position. And the second question I didn't understand.
That was my question. Yes, the second question is that what effect will happen to my pipeline if I will use a gate valve as a check valve?
Could be that you will be experiencing higher pressure than the PN rating of the pipes, okay, and the components, so you will not protect completely your system, okay? It will not react to changes in flow, in supply pressure, etc., etc.
Production ratio. With respect to gate valve, with Burman valve, can you achieve higher production ratios?
I guess if you change the position of the gate valve, you can break the pressure as much as needed, but you need to come and do it, okay?
While you were talking about surge analysis, you said the valve closure time should be more. So how do we decide the parameters to, like, what should be the maximum and minimum limit to decide the valve closure time?
Again, this is we do it in the full surge analysis, specifically per each project, okay? But definitely the approach is that the valve need to open fast in splits of seconds because the water are coming very fast, and it needs to close gradually because we don't want it to create additional surge, okay? So this is an issue that we examine all the time inside of the surge analysis, okay?
The project we worked on, like we were having valve opening time like in within 1 or 2 seconds, and closing time we used to keep more than 10, but less than 50 seconds, like 30 seconds, 35 seconds like that. So what should be, can I keep it to 100 seconds? Can I keep it to 2 minutes, 3 minutes, like that?
Actually, I don't know any time rule about that. When we do the specific surge analysis for each project, we design it very specifically. Amay, do you have something to comment here?
Yeah, really it is.
I'm very careful with the surge analysis. I will not give you any numbers.
It actually depends on your line length. What is your, like, how much is your rising main length from the pump station? So your ideally what, like, since I was under Tal, I'm like, Tal is a member in BUMAD and he's a surge expert. So he might know everything. So what we used to do is based on the rising main length, at least your 2 to 3 cycles of your surge should go, because what was been as it typically analyzed is once your pump shuts off and either your first, second or third wave is the most critical wave in your surge analysis. So your wave of the surge wave from the pump station till your dead end of your system. So if it goes and comes back 3 times, it is not water wave, it is actual wave of the surge. So it should cater for at least 3 to 4 waves, and hence we do surge analysis for 10 to 20 times of this thing, but your surge opening time is for at least 3 cycles approximately.
We have one assembly unit. Main material is coming from this side, but soon we have hired the place and probably we will be functional in this year.
Wonderful. Really. It was fun. It was interesting, and it was fun for me. Thank you. Thank you. Thank you, Anay.
If nobody has any other questions, we can close the session. Thank you to the WOMAT for coming right from Israel periodically to train us and give us a lot of knowledge. Their role goes beyond just selling valves like they said themselves, but time and again they keep coming and they keep imparting their knowledge, which builds a little bit on our knowledge every time, and that cycle keeps continuing as we grow and as we deliver projects. So we'd like to thank them as well and hope to see them maybe in a couple of years again with some more knowledge.
And also Farstad was in Israel.
Yes.
Vermat QP, so we welcome you to come to Vermat qualification program as well.
Right. So if we have any other questions that you don't want to ask in a group, you can catch these guys. I think they'll be around for about maybe half an hour. Is fine. So you could ask them the question. You can ask them any questions you still have. But otherwise, we close this session, and do give us some feedback. Probably informal feedback is fine as well. I won't send out any forms of how do you like the training, and if you'd appreciate any more trainings in the future. Thank you.